From Indonesia's Mount Tamobora to the Caribbean's Mount Pelée, these fiery explosions reshape landscapes, claiming lives and altering ecosystems. The power of volcanic eruptions often surpasses even the most powerful human-made explosions, capable of impacting everything from the atmosphere to oceanic currents. Even as scientists strive to predict these eruptions, the unpredictability of the Earth's inner workings often keeps us on edge. Between 2018 and 2022, two immense underwater volcanoes erupted in the Pacific and Indian Oceans, changing the course of history. While these eruptions initially brought devastation to human life and property, the scientific community quickly realized that their significance ran much deeper. Beneath the surface, researchers discovered a previously hidden and remarkable geological feature. The eruptions didn't just cause destruction, they left behind something extraordinary beneath the ocean, unveiling secrets of our planet's deep interior. Let's dive deeper into what transpired beneath the ocean's surface, where a volcano's explosive eruption not only changed the landscape, but also gave us new insights into our planet's geologic mysteries. Volcanoes, the Earth's natural pressure release mechanism. Volcanoes, as we know them, are natural structures formed by the Earth's internal heat forcing molten rock to break through the surface. While we often picture a towering peak spewing fiery lava, many volcanoes are submerged beneath the oceans. These underwater volcanoes, called submarine volcanoes, play a crucial role in the Earth's dynamic processes. Rather than forming towering mountains, these hidden volcanoes lie deep beneath the waves, typically along mid-ocean ridges where tectonic plates interact. Their eruptions are often less visually dramatic but just as important in regulating the planet's heat balance and shaping oceanic environments. The Tonga eruption, a historic event in volcanic activity. In January 2022, the world witnessed a volcanic eruption that captured global attention. The eruption occurred off the coast of Tonga, in the South Pacific, sending plumes of ash and steam into the sky. This spectacular event, which took place on January 13, sent shockwaves across the globe, both figuratively and literally. What made this eruption so extraordinary was its size. The eruption not only created a tsunami that affected multiple countries, but it also unleashed a cloud of volcanic material that traveled far and wide. The shockwaves from the eruption circled the Earth multiple times, a phenomenon that hadn't been recorded in such a way before. The eruption's ash cloud reached unprecedented altitudes, creating a visual spectacle from space. The island nation of Tonga was hit hard, with ash blanketing its capital, disrupting communication, and leading to widespread chaos. Yet, this eruption left behind more than destruction. It left scientists with a puzzle that would require years of study to fully understand. The power and unpredictability of volcanic eruptions. The scale of the Tonga eruption was beyond anything scientists had expected. It wasn't just an isolated event, it was a reminder of the immense power beneath our planet's surface. The eruption generated shockwaves that traveled faster than the speed of sound, making it a seismic event of global significance. Satellite data showed a massive eruption, ejecting ash, gas, and water vapor high into the stratosphere, disrupting local weather patterns and creating a ripple effect across the globe. What followed was a fascinating discovery about the eruption's lingering effects. Scientists found that the eruption had injected vast amounts of water vapor into the stratosphere, potentially influencing global weather patterns for years to come. The impact of water vapor on Earth's atmosphere. The Tonga eruption wasn't just a geological event, it was also a climatic one. The amount of water vapor released into the upper atmosphere was unlike anything seen before. This water vapor, which was injected into the stratosphere, formed a giant cloud that could affect the global climate in subtle yet significant ways. The water vapor could potentially contribute to changes in the Earth's weather systems, possibly. To put it into perspective, the eruption released enough water vapor to fill tens of thousands of Olympic-sized swimming pools, making it one of the largest contributions of water vapor into the stratosphere in recorded history. This discovery opened new avenues for climate research and demonstrated the profound interconnectedness of geological and atmospheric systems. A rare and unprecedented volcanic event. Scientists were stunned by the magnitude of the Tonga eruption. Not only did it surpass many previous eruptions in scale, but it was also a rare event that had global repercussions. The eruption's effects were felt worldwide, from tsunami waves that reached distant shores to changes in the composition of the upper atmosphere. Despite its devastating impact on nearby communities, the eruption sparked new interest in the study of submarine volcanoes. The scientific community recognized that such events were not isolated incidents but part of a much larger geological puzzle, one that we are still piecing together. The submarine volcanoes beneath our oceans. While most volcanoes we encounter are above the surface, the majority of volcanic activity occurs beneath the ocean's surface. Submarine volcanoes are part of a vast network that covers much of the Earth's ocean floor, and many of them remain hidden from view. These underwater eruptions are often less dramatic but just as important in maintaining the planet's geological balance. Many of these volcanoes are located along tectonic plate boundaries, where the Earth's crust is constantly shifting. These regions are hotbeds of volcanic activity, yet they often go unnoticed because of their location beneath the waves. However, submarine eruptions can have just as significant an impact on the environment as their land-based counterparts. The Mayotte volcano, a hidden giant. In 2018, an unexpected volcanic event occurred near the island of Mayotte, located in the Indian Ocean. For months, residents of Mayotte experienced frequent tremors, signaling an active volcanic event beneath the sea. Eventually, scientists discovered an underwater volcano that had been erupting for months without being detected by most people. This volcano, which became known as Fonimau, was found to be erupting at an astounding rate, producing thousands of cubic meters of lava every second. In just a few months, the eruption formed a massive underwater mountain that rose to impressive heights. By the end of the eruption, the newly formed seamount stood taller than many of the world's tallest buildings, revealing the immense power of underwater volcanic activity. The future of volcanic research. The Tonga and Mayotte eruptions are just two examples of the many hidden forces at work beneath the surface of our oceans. As scientists continue to study these underwater volcanoes, new discoveries are being made that could reshape our understanding of how the Earth's geological systems operate. With millions of submarine volcanoes scattered across the planet, there's still so much left to uncover. As we explore these hidden giants, we can gain deeper insights into the forces that shape our world. While we may not fully understand everything that occurs beneath the ocean's surface, these eruptions offer us a unique glimpse into the dynamic and ever-changing nature of our planet.